In 1919, Ernest Rutherford actually became the first person who discovered that if you take two stable isotopes and react them together, you can produce a radioactive isotope. And what he did was take nitrogen-14 and react it with an alpha particle, and he produced oxygen-17 plus a proton. And this was the first time that it was possible to convert one element into another by going through nuclear transmutation. And in order for this to happen, you crash two particles into each other. And this reaction actually paved the way to particle accelerators. And with particle accelerators and getting particles, getting closer and closer and closer to the speed of light, particle accelerators made it possible to synthesize the transuranium elements, so the elements that are greater than atomic number 92. So these were, because we have these things called particle accelerators, and we can take a neutron or an alpha particle or we could take other atoms and crash them into stable isotopes, and this produces our new elements. Now, light elements are for the most part not radioactive, but they could become radioactive by bombarding their nuclei with the appropriate particles. So, for instance, tritium, which is an isotope of hydrogen, can be prepared by taking lithium-6, so taking a stable lithium isotope, reacting it with a neutron, and this produces tritium plus an alpha particle. And then tritium can be decayed by emitting a beta particle. So we can take tritium and it breaks apart by giving off a beta particle, but it also forms helium-3. Okay, which again, helium is a noble gas, but it's not a it's still not a stable isotope. Now, many isotopes are prepared by using neutrons as projectiles. They have no net charge, and so they're not going to be repelled by the nucleus. So a neutron is really the best way to go for these. Now, if a proton is used as a projectile, the proton must have enough kinetic energy in order to overcome the electrostatic repulsions between the proton and the nucleus, and we can make that happen by using a particle accelerator. And a particle accelerator, and this is what we're looking at here, a particle accelerator uses electric and magnetic fields to increase the kinetic energy so that a reaction can occur. And basically, there's specially charged plates that alternate the polarity, and this is going to speed up this particle, and that once the particle's at the cruising speed, it's actually guided out of the accelerator to begin the reaction. All right, so there are quite a few of these particle accelerators all over the country. So there's a really famous one at Argonne National Labs, which is right outside Chicago. There's another particle accelerator that's a little bit nearby. It's up at Michigan State. The biggest one in the world is the one that produces the hadron particle, and that's between the borders of France and Switzerland, and that actually finished construction in the late 2000s.